Hi, my name is Tianyu. The project name is Cognitive Assistant. This is a piece of work advised by Professor Dan Siewiorek and Dr. Asim Smailagic. So this project is aimed towards manufacturer training. Manufacturer training is a hard task. It requires dedicated stuff. It requires dedicated equipment, and most importantly, it will incur productivity cost. So the current approaches in manufacturer training are two approaches, which is in-person training, and we have these virtual help desks. For in-person training, the coach has to be in person and stand behind the operator to give advice. And the limitation is quite obvious. The coach has to be physically present. And for the virtual help desks, the coaches do not have to be physically present, but only one coach can train one operator. So there's still a lot of limitations. And to solve these limitations, a class of virtual coaches called scripted coaches are proposed. And however, the scripted coaches are only able to provide course level instructions. So our goal of this project is to combine the scripted coaches with human coaches in order to provide more fine-grained instructions and make the training more efficient. So here are the two main methods that we used in this project. The first is video streaming, and for video streaming, we mainly used a Python module called 0MQ, OpenCV, and Socket. And for object recognition, we used YOLO, faster RCN, and more traditional computer vision techniques, which is template matching. So now we're talking about the project structure. So the operator is gonna start his operations here, and his operation is gonna be recorded by a video camera, and all the video strip of clips are sent to the server, which is right now the operator's computer, and it's gonna be done object detection, object tracking, and state recognition. And if everything is alright, then the step-by-step instructions are sent back to the operator and to keep the operation going. However, if there's an abnormal state, then the server will be able to recognize the abnormal state and be able to contact a remote human coach. And the remote human coach will now be able to provide expert instructions to keep the operator's operation going. So let's get started. And as you can see here now is the front case of the TI-84, and you can see it is recognized by the algorithm, and the instruction is to open the front case. And then as what we did, we opened the front case. And then it recognized that this is the TI-84 calculator, and the instruction will be to flip the calculator. And then we do what the instruction says, which is to flip the calculator. Now it recognized that this is the back case of the calculator, and the instruction says get more batteries. And we do what the instruction says, which is to get more batteries, and recognize one, and also recognize the battery. So now it recognized four batteries. So what if the operator instead use a big battery? Then you see the algorithm is able to recognize this is the big battery, and it will say please replace the big battery with AAA batteries. Right. So now we have enough batteries, and it says open the back case using the green handle, which is the handle surrounded by the green box, and then we open it. Right, so it recognized the back case is opened, and it said insert batteries to the blue box and close the case. And we do what it says to do. We insert the batteries. Maybe I've internalized it because this was actually the title of the project when it was given to me. I think it's fitting. It's like, the model, the machine is speculating. And then we close the case. Yeah, all right. It says, so now it recognized the back case, and the instruction says finish, and which means we're done.